A very good evening to everyone. Myself, Professor Suresh Atani, Assistant Professor, Department of Mathematics, CS Bembalgi Arts, Shayamar Palaresha Science and GL. Commerce Degree College, Ramdurg. Okay, as a Professor of Mathematics, I want to say one quote. The great mathematician Paul Lamus says that the only way of understanding the mathematics is to do the mathematics. That means you should be in touch with the mathematics every day. Then only you can learn the mathematical concepts very easily. Then only you can understand the most important concepts of mathematics. With this quote, now I would like to start the important topic or the concept called sequence. Okay? This sequence concept is there for third semester of BSc students of Rani Channamma University, Belagavi. Okay? So this sequence word definition, first I would like to define by the general concept. Okay? If I say that you have to do a line height wise, if I say this to our students, definitely they will form a one straight line of students height wise. That means that arrangement of students in a line height wise, it is a one sequence, because the height wise means there is a one rule. According to the rule of height wise, they arranged or they formed a line. This is called a sequence in general. But now I would like to define the sequence mathematically. To define the sequence mathematically, there is a need of concept called a function. Okay, now I will consider a function f. Okay, f is a function. F is a function from A to B. Okay, here A and B are two non-empty set. F is a function from A to B means you can write this as f is a function from A to B. It can be denoted like this. Here A is called a non-empty set, but it is a domain of a function f. And B is also a non-empty set. It is called codomain of a function. Okay, if I say that there is an element A belonging to A, that means for every A belonging to A, there exists f of A belonging to B. This f of A is called the image of an element A belonging to A. Okay, it is nothing but a definition of a function. According to the definition of function, for every A belonging to A, there exists an element or the image belonging to set B. This is called a function. A and B should be the non-empty set. But when you call the function f as a sequence, that is the most important thing. Instead of the set A and B, here A and B are two non-empty sets. But if very particularly the set A is natural number set n, and very particularly this set B is R, that means a real number set. If this function f is a function from set of natural numbers to set of real numbers, then we can say that f is called the sequence of this function. F is called the sequence. It is not only a sequence, it is infinite real sequence, because the set of natural numbers is infinite. This is a domain, and codomain is a real number set. That means all the values are real numbers. Then by using this function, f is a function from n to r, that sequence is called infinite real sequence. Okay, that is called infinite real sequence. Infinite is because both n and r are infinite sets. Very easily. Okay, it is a real because codomain, it is a real set of real numbers. That means every image of any element from n, it should be real number. Okay, so now it is a set n means it is having the natural numbers only, that is n equal to 1, 2, 3, 4 and so on. There may be nth term n and so on. It is a infinite, so there is no end. For the first natural number n equal to 1, okay, for the first natural number n equal to 1, the value of a function for n equal to 1, function becomes f of 1. For n equal to 2, function is f of 2. For n equal to 3, function is f of 3 and so on. For the number n, for nth term, if it is n, it becomes f of n and so on. These are called the values of a function for every positive integer or for every natural number belonging to the set of natural numbers. That means all these are called images of a unique or every natural number. These are belonging to the set of real numbers. Okay, that means all these are the terms. First term f of 1, second term f of 2, third term f of 3. The nth term is going to be f of n, but for our convenience, in a sequence concept, you can write the terms of a sequences as, instead of writing f of 1, now we will write it as a1. The second term f of 2 can be written it as a2. f of 3 can be written it as a3, then and so on. The nth term, instead of writing f of n, I will write it as an and so on. These are called the terms which are present in the sequence, which is defined by the function. F is a function from n to r, natural number set to real number set. Okay, it is called infinite real sequence. But the nth term an, this nth term, it is always in between. It is always in between an minus 1 and an plus 1. In between there is a term an. This is called the nth term. Okay, this is called the nth term of a sequence. This an minus 1 means it is called n minus 1th term of a sequence. This an plus 1 is called n plus 1th term of a sequence. Okay, so now this an minus 1 is called as predecessor. It is called predecessor of an, and this an plus 1 is called successor. This is called successor of the nth term an. Predecessor means the one step behind an. So before an there is a term an minus 1 very easily, and after an there is a term an plus 1. These are called predecessor and successor. Okay, but for our convenience, when you define or when you write a sequence, you have to write a1, a2, a3, an plus 1 and so on. Instead of writing that whole terms, instead of writing all these terms, just you can represent any sequence by the denotation as an in a flower bracket. An in a flower bracket means it represents a sequence on the basis of nth term of a sequence. So instead of writing this, you can write it as a1, a2, a3, a4 and so on. Nth term is an. So you can save the time, or instead of writing this, just write it as a sequence an. Okay, one thing you can remember, that the natural numbers or the elements or the numbers belonging to the domain of a function which defines the sequence all are natural numbers or positive integers, and the terms present in a sequence which is defined by the function f, all these belonging to the real number set. That means a1, a2, a3, a4, an, all these are elements of real numbers. You can write on that. All these belonging to the set of real numbers. Okay, it is called the definition of a sequence. But what I told, the definition of a sequence, you have to check that it is right or wrong by taking a sum of the examples. In that, first one, okay, I will take the examples now. Examples number 1. First, I will take the sequence 1 by n square. In a flower bucket, I written that 1 by n square, it represents flower bucket n. Okay, now it is nothing but a sequence with the nth term 1 by n square. Already we know that it is defined on the basis of natural numbers because the domain is natural number. Okay, so now the first number, natural number is n equal to 1. Okay, 1. So now I will take that n equal to 1 means it becomes 1 by 1 square. 1 square is 1. Okay, next 1 by 2 square, the second term n equal to 2, that is 1 by 2 square is 4. Next 1 by 3 square, that becomes 1 by 9. Next one 1 by 4 square, that becomes 1 by 16, and so on. This is nothing but sequence of reciprocals of squares of a natural number. Is it right? Or sequence of reciprocal of squares of a positive integers. Okay, it is a one example for the sequence. Now I will take the second example. I will take the second example as 2n. Here the nth term is 2n, that is an equal to 2n. Okay, so if I take n equal to 1, the first term, it becomes 2. If n equal to 2, it becomes 4. For n equal to 3, it is 6. For n equal to 4, it is 8, and so on. Okay, this is sequence of even numbers, right? This is a sequence of even numbers. Now I will take another one, third one, 2n minus of 1. Okay, here 2n minus of 1. If I take the first natural number n equal to 1, 2 ones are 2, minus 1, it is called 1. Now second natural number, 2 2s are 4 minus 1, it is 3. Next 2 3s are 6 minus of 1, it is 5. Next it becomes 7 in general, and so on. You can call that it is sequence of odd numbers, right? You can check that. The every term present in this sequence is odd number, right? It is a sequence of odd numbers. The most important example, third one. Now I will take that as sequence minus 1 raised to n. Okay? Example number fourth one. It is minus 1 raised to n. In a flower bracket, minus 1 raised to n is that. That means an equal to minus 1 raised to n. If I take n equal to 1, that is minus 1 raised to 1. Minus 1 raised to 1 is minus 1. If I take n equal to 2, for minus 1, if it is a even number, for the power, if the power is even, that value is always positive. Next, minus 1 raised to 3. Now, power of minus 1 is odd number. At that time, it is minus 1. Next, minus 1 raised to 4. This is plus 1. Next, minus 1, and so on. This is a sequence which is altering or alternating sequence, because minus 1 and plus 1 are continuously alternating with respect to the natural number set from the domain. Because when you take n equal to 1, 2, 3, 4 and so on, the values are minus 1 plus 1, minus 1 plus 1, minus 1 and so on. This is called alternating. This is called alternating sequence. Okay, the last, fifth one. In the fifth example, it is related to a particular case of sequence, that is called constant sequence. It is called constant sequence. But when you call the given sequence as a constant sequence, that is the important thing. Now I will take that the sequence an, if sequence an is equal to k, comma k and so on. That means this is representing a sequence an, but every term of a sequence is k itself. First term k, second term k, third term k, and nth term will be also k. That means the terms of the sequence are not changing at all. This sequence is called constant sequence. Okay, it is called constant sequence. This is called constant sequence. Example for this is, I will take that n raised to 0. Now I will take this as n raised to 0. For the first natural number, it is 1 raised to 0. 1 raised to 0 is 1. Next, 2 raised to 0 is 1. 3 raised to 0 is 1. Why I am writing all these numbers as 1? Because there is a fundamental concept, anything raised to 0 is equal to 1. Okay, so now 1, 1, the next term is also 1 and so on. That means the terms of a sequence n raised to 0 all are same, all are constant. These type of sequences are called constant sequences. Okay, so this is all about the definition of a sequence. Okay, and some of the most important examples of a sequence. Okay, with this I will wind up this session. If you like the video, click the like button, or if you want to watch remaining or other videos related to these concepts in the next class, click the subscribe button also. Thank you one and all.